Hello everyone, welcome to Smart Introduce YouTube channel. In the today's video, we are going to discuss weekly contest 408 lead code solutions. So the first question is, find if digit game can be won. You are given an array of positive integers, nums. Alice and Bob are playing a game. In the game, Alice can either choose all single digit numbers or all double digit numbers from nums, and the rest of the numbers are given to Bob. Alice wins if the sum of her numbers is strictly greater than the sum of the Bob numbers. So if Alice uses a single digit number or the double digit number, if the sum is greater than the other numbers, Alice wins or else Bob wins. Return true if Alice wins the game or else return false. Okay, let's see. So for example, if Alice is picking all the single digit numbers and let's say the single sum is equals to x, or and if the single sum is x, the double sum will be let's say y. So let's say Alice is picking either x or y. Can you tell me what is the only case where Alice can lose? Alice loses only when your x is equals to y. Yes, if your x is not equals to y, which means either one of them will be greater. If Ls picks that greater number, Ls always wins. So Ls can't win when only x is equals to y. And if you look at the first sample input, what is the sum of the single digit numbers? 1 plus 2 plus 3 plus 4 is 10. And what is the sum of the double digit number? Which is 10. X is equals to y. So Ls is winning or losing false. And for any other case where sum of single digits is not equal to sum of double digits, we will always truly win. So let's quickly discuss the code. So we need to count the single digit sum and double digit sum. So let's say I'm taking two variables. Single sum equals to 0 and let's say double sum equals to 0. I'll iterate on the array for int I is than nums dot length I plus plus. So how to check if a number is single digit? If nums of I is less than 10, it is single digit, right? I'll add it into my single sum plus equals to nums of I, else I'll add it to my double sum plus equals to nums of I. Now, when will Alice win? If your single sum is not equals to double sum, we can return true, or else we should return false. So let's run for the sample test case. Okay, this is capital S. Any more errors? No. Let's submit and see. Done. So for the next question, find the count of numbers which are not special. Okay, let's read the question. You are given with two positive integers, L and R, and for any number x, all the positive divisors of x except x are called the proper divisors of x. So proper divisors, a number is called special if it already exactly has two proper divisors. For example, a number 4 is special because it has proper divisors 1 and 2. So 4 has only two proper divisors that are 1 and 2. And the number 6 is not special because it has 1, 2, 3 as the proper divisors. So if it is having only two proper divisors, it is called special, or else it is not special. And given L and R, we need to return the count of numbers in the range of L, R that are not special. Okay, let's look at a sample example. The given L and R are 5 and 7. So 5, 6, 7. So 5 has and output is 3 explanation. There are no special numbers in the range of 1 to 5. So 5 has the divisors 1 and 5. So without counting 5, we have only one divisor. So it is 5 is not special. It has 1, 2, 3. More than 2, not special. 1, 7. So except 7, there is only one proper divisor. So this is also not special. So how can we solve this? If you observe, let's take a prime number p. For a prime number p, what are the divisors? The divisors are 1 and itself, but that is p. Yes, for a prime number, the divisors are 1 and itself. Now, if you take p square, What will be the devices? What will be the devices? Devices will be 1, p, and p square. So if you don't count p square, how many devices are there? 1 and 2. Yes. So queries of the question. Can we tell that all the squares of the prime numbers are special? Yes. All the squares of the prime numbers are special, and the rest of the numbers are not special. So between L and R, if we can simply count how many squares of the prime numbers are there, we can know how many specials are there. Yes. And if I get the count of specials, if I take let's say C is the count of special numbers, how can I get the count of non-special numbers between L and R? Simple, right? If L and R are equal to R minus L plus 1 will be the total numbers minus C will give me answer. So how can we calculate all the prime numbers between L and R? What is the simple way to calculate all the prime numbers between L and R? We can simply use them. See what I do? So let's discuss the code. Okay, so let's start with the code. First, we need to calculate the prime numbers, right? So to calculate the prime numbers till R, we require only till square root of R. So SQRT. So basically, since we are doing square of the prime numbers, if we calculate the prime numbers to square root of R, it will be fine. And let's say we are declaring a vector of type bool to store if it is a prime number or not. And let's say we are declaring another vector of type integer. So in this vector, let's say we are storing the prime numbers. And let's manually declare v of 0 and v of 1 as false, indicating they are not prime. And let's iterate. Let's say for int I equals to 0. Since 0 and 1 are already marked, let's say I equals to 2, I less than or equals to n, I plus plus. I need to, if it is a prime number, I'll mark all its multiples as not prime. That is our C algorithm. So if your v of I is equals to true, what should I do? I should mark all the multiples of that current prime as false. Yes. So since it is prime, first I will push it into my vector primes dot push back of I, and then I'll iterate on the multiples of I. Let's say for int k equals to I into I, k less than or equals to n, k plus equals to I, v of k equals to false. So with this, we'll calculate all the primes. After calculating all the primes, what should we do? We should calculate the answer. Yes. So we need to find out of all these primes, how many squares of these primes are in range of L and R. Yes. So let's say for I'll iterate on my primes, and let's say int special equals to or temp equals to. Now I'll calculate if my current prime square, that is I into I. Now this is my prime square. Now I need to see if this is in range of L and R. Yes. So if your temp is greater than or equals to L, and if your temp is less than or equals to R, what should you do? So let's say we are simply maintaining the count. Int count equals to 0. I'll simply do C++ count plus plus. And then what should I return? I need to return my total range R minus L plus 1 will give me my total range between R and L. From this, I need to subtract my count to get this count of the non-special numbers. So let's run and see the code. So sample test case got accepted. Let's submit it. Done. Let's move on to the next question. So the next question is count the number of substrings with dominant ones. We are given with a binary string S, return the number of substrings with dominant ones. A string has dominant ones if the number of ones in the string is greater than or equal to square of the number of zeros in the string. So the number of ones should be greater than or equal to square of the number of zeros. So zeros whole square. So it should be greater than or equal to the square of the number of zeros. So if this is true, it is a dominant one. Let's see the sample example. So if you see for this example, 0, 0, 0, 1, 1. This is a given string. If you see, if you consider this string, how many zeros does it have? It has 0 zeros and 0 ones. Now, is it valid? 1 0 and 0 1, sorry. So it is not valid. So this is not valid. Similarly, this substring is not valid. This substring is also not valid. But if you look at this substring, how many ones does it have? 1. How many zeros does it have? 0. So 1 is greater than or equal to 0 square. So this is true. This is one valid substring. Similarly, this is one valid substring. And similarly, this is also one valid substring. Yes. Do we have any other answers? No. Do we have any other answers? And if you look at this, if you consider this substring, how many ones does it have? 1's equals to 1. 0's equals to 1. 1 is strictly greater than or equals to 1. So this is also one valid substring. Yes. So we have 1, 2, 3, 4, 5 valid substrings. Yes. So single ones, 2 single ones, 1 0 1 and 1 double 1 and 1 0 1 1. So total answer is 5. Now how can we solve this question? What is the brute force way? Considering all substrings. So if we consider all the substrings, if we write a pseudocode for I in range of n, and similarly for j in range of n, I combine, we'll consider all the substrings, and for every substring we can use a carry forward technique. Carry forward to count the number of ones and zeros, and we can see if it is valid or not. How much time will it take? It takes order of n square. Now I want to optimize this time complexity. What can I do? Now, if you look at this condition, that is 1 is greater than or equal to zeros. For example, if the 0, what can be the 0 counts? What can be the 0 counts? For example, for a string to be valid, how many zeros should it have? For a string to be valid, how many zeros should it have? So here the key insight is, for a string to be valid, as the 0 count increases, the 1 count should increase quadratically. Yes, for a string should be valid, the 0 count should strictly be less than square root of n. Because if it is greater than square root of n, what is the square root of n whole square? It is n, right? Yes. So if the 0 count is greater than n, the ones count should be, if the 0 count is greater than square root of n, the ones count should be greater than n, which is not possible because the string length is only n. Yes. So this is one of the observation. The number of 0 counts can be either from 0 to square root of n. So the number of 0 counts should be between 0 and square root of n. And what else can we observe? Can we simply do? Can we simply eliminate this loop? And can we generate all the possible substrings with this 0 count? So for example, I'll take the 0 count 0, 1, 2, 3. For every zero count, I'll try to generate a substring which consists that many zeros using the sliding window. Yes. So first I will iterate on the possible zero counts. Int I equals to 0 till square root of n. For every zero, I'll iterate on the string and generate all the substrings with exactly that many zeros in it and calculate the answer by using sliding window. So I can use the sliding window to generate all possible substrings with exactly I zeros. By this, we'll cover all the possible zeros which we can have in substring to be valid. And with that I zeros, how many ones should I have? I should definitely have I into I ones. So I'll try to consider substrings with I zeros and I into I ones by using the sliding window. So until this is valid, I'll increase the window size. Once it is not valid, I'll decrease the window size. And how can I do this easily? Let's take this example and see. So the given example is 1 0 1 1 0 1 1 1 0 1. So instead of iterating on the entire string, I'll try to store the positions of the zero. This is 0, 1, 2, 3, 4, 5. If I store the positions of zeros, that is 1, 4, to generate substrings with exactly two zeros, I should take these two zeros. Let's say first I'll try to generate a substring with exactly 1 0. So this definitely I should count. If I count this, can I know if I count till this? So by using these positions of the zeros, we can also keep track of the count of ones. Yes. And while generating subarrays during sliding window, we will count all the subarrays which will exactly have k ones and k zeros and k square number of ones. Yes, once we get a subarray of this length, we can always increase and add some ones to get a valid subarrays. Yes, and then we can count all the number of all the valid subarrays. Let's move forward with the code for better understanding. Let's start with the code. Let's say I'm declaring an answer to count the number of valid subarrays. Now, let's say I need the string length, so I'll store it in S. Now, I will iterate on all possible zeros for I k in range of 1, comma. I need to iterate till square root of n. So, point 0.5 plus 1. Now, I need to generate a substring with exactly k number of zeros. Yes. So, let's say I want to store the zeros, the positions of the zeros in a DQ. And I want to count the number of ones in my current window. Okay. Now I'll iterate on the string. So while iterating on the string using sliding window, I want to generate exactly k number of zeros and k square number of ones. Okay. So I need to keep track of the count that I'm getting and keep track of the zeros in my DQ. So if your S of I, if your S of I equals to 0, what should I do? I should push it into my zeros. Yes. Zeros dot append of I. I need to keep track of the position of the zero that I'm getting. Yes. Else, what should I do? I should increment the count of my ones. Yes. And after calculating it, what is our condition? If your length of your zeros is equals to k, that is, when I have generated a substring with k number of zeros, and if your ones is greater than or equals to my k square, what does that mean? What does that mean? I can calculate my answer. I can add it into my answer. How much should I add into my answer? Let's keep it a second. Before this thing, let's try to figure out some of the other. Now, when you have added a zero, what what happens if you are adding more than k zeros? What you should do? Which zero should I remove? I need to remove the leftmost zero. So let's say I'm removing the leftmost zero. Zeros dot pop left. Yes. And along with removing the leftmost zero, what should I do? All my ones which are in between my leftmost zero and the next zero to it should be also removed. All those ones which we consider should also be removed. So what should I do? In order to get the number of ones which we consider, I need to have the last pop zero. Yes. So let's say I'm maintaining the last zero index. Initially it will be -1. And what should be the condition? If your length of zeros is greater than k, what you should do? So if this is true, what you should do? You need to remove a zero. Yes. Along with removing a zero, you need to remove the count of the ones which you have counted between your last zero and this current zero. Yes. So which means you need to maintain the index of the last zero. So while popping it, what you should do? You need to copy it somewhere to maintain the index, and along with it, you need to subtract how many ones will be there. So your leftmost zero will be, so your leftmost zeros will be at this index minus to your last zero minus 1 will be your number of ones between your last removed zero and the leftmost zero. Yes. And along with that, what you should add to your answer? Now, you consider your substring from leftmost zero to the rightmost zero. Yes. Once this is valid, once this is valid, you can either increase this substring to the right side of it or to the left side of it. Yes. But if you we can only start adding from the k squared one from the before your current position. Yes. Before your current position, after considering the k squared one, that is k square ones, then only you can add the number of ones. So you need to add the minimum of zeros of 0 minus your last zero, that is extending out on the right side, and ones minus k square plus 1, because we don't want to duplicate things. Yes. Now after this, what you should do? Is this done? That's it. Is there anything else left? If you look clearly, we have counted all the substrings we have counted have zeros in it. Yes. But still there are some valid substrings with no zeros. If you see this valid substring on the left side, 1 1 is also valid but no zeros in it. Did we count the substrings which has no zeros? No, right? We need to count them also as well. So let's say I'll start from I equals to 0 and I'll count all the substrings. So I'll iterate on messing. So I need to see how many ones are occurring together. I while your I less than n. If your, let's say, s of I equals to 0, what can I do? If it is 0, I should not count anything. I'll simply do I plus equals to 1, and I'll go to the next iteration. And if it is 1, what should I do? I need to count the number of ones which are occurring. So let's say int c equals to 0 to count, and your I'll iterate while I less than n, and s of I equals to 1. I'll simply do count plus equals to 1, and along with I'll increment my I because I need to move to the next indexes. Now after doing this, how many such subarrays will be added? If I have 3, if I have n ones which are occurring continuously, how many subarrays will be there? How many subarrays can I want? Same, right? Array of length n. Yes, how many subarrays will be there for an array of length n? N into n plus 1 by 2. So for my answer, I need to add count into count plus 1 by 2, and then I'll return my answer. Let's run the code. Okay. For I in range of invalid syntax. Okay. I'm missing n for I in range. Okay, what's happening here? Okay, this greater than k should be outside. Do you have any other errors? So sample test cases are accepted. Let's submit and see. Done. So these are the solutions for the first 3 questions of the LeetCode Weekly Contest 408. So if you like the videos, please follow and subscribe our YouTube channel.